Hello friends, welcome to Risingpearl.com. Today we are going to learn about series 5 where we're going to learn about polynomials. This is webisode number 9. Today's topic, friends, is geometric representation of zeros of a cubic polynomial. I hope you're following us along in this series at Risingpearl.com. Friends, in the last 5 episodes we have looked at how do we draw a graph for a linear polynomial, a quadratic polynomial, and a cubic polynomial. Also, we have seen that can we draw any conclusion about zeros of a linear polynomial and a quadratic polynomial by looking at their graphs. Today, we are going to try to answer that same question for a cubic polynomial. So friends, let's get started. Now first, we have to draw some cubic polynomials. So let's write a cubic polynomial x cubed minus 9x. This is going to be our first cubic polynomial. Now, how do we draw this cubic polynomial? For those of you who are following us along, you know that this is exactly the cubic polynomial that we used in the last example, the last webisode. And the reason why I have picked the same polynomial is that for x equals minus 3, x equals minus 2, x equals 1, x equals 0, x equals 1, x equals 2, and x equals 3, I have already calculated these values, because in order for me to draw any graph, I have to find out the values of the polynomial at each of these values of x. So for minus 3, this value will be 0. For minus 2, let's find out. So I know that these values will be 0, and I already know these values, but I think just for the sake of it, let's just find out. So what will be the value at x equals minus 2? The value of the polynomial at x equals minus 2 will be minus 2 cubed minus 9x. X is minus 2. So minus times minus times minus is negative. 2 cubed is 8. Minus times minus is plus. 9 twos are 18. So 18 minus 8 is 10. So this is 10. This will be, so let's find out this one as well. So p at minus 1, the value of the polynomial is at x equals minus 1 will be minus 1 cubed, because it is x cubed, minus 9 times x is minus 1. So you will get minus times minus times minus negative. 1 cubed is 1. 9 minus 9 minus times minus is plus. 9 ones are 9. 9 minus 1 is 8. So this will be 8. This value will be minus 8. And this value will be minus 10. So these values, all of these values, we have calculated earlier. And so we are simply just reusing these values over here. Now, let's draw the graph of this polynomial. So first, let's write all the values that we have seen. So I have simply just put that table in here for these values of x, minus 3, minus 2, minus 1, 0, 1, 2, and 3. What are the corresponding values of the polynomial? That is 0, 10, 8, 0, minus 8, minus 10, 0 respectively. Now we would want to draw these values, these points on the graph, and find out what is the exact graph for this polynomial. So we know that, so this is the origin. This is the origin, right? That is the 0, 0. This is our x-axis, x, x dash. This is y-axis, y, y dash. We know that as you go on the left side on x-axis, the values are negative. As you go on the right side of x-axis, right side of the origin on x-axis, the values become positive. Similarly, as you go up on y-axis from the origin, as you go up on the y-axis, the values are positive, and as you go down, the values are negative. So friends, here the first point is minus 3, 0. So we go 3 units on the left, 1, 2, 3, and the y value is 0, so this point is on the x-axis. Similarly, let's get the other points on the graph. So our second point is minus 2 and 10. So for y, so x minus 2, so 2 units on the left. Y is plus 10, so we go up 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is our 2, minus 2, and 10. Similarly, we can draw minus 1 and 8. We can draw 0 and 0. We can draw here 1 and minus 8. So for x equals 1, this time we go on the right side of x-axis, x equals 1. The y value is minus 8. So now we go down on y-axis. This is 8 units down. So this point is 1 minus 8. Similarly, we see 2 minus 10, and finally we have 3 and 0. So friends, like I have mentioned earlier, now it will take you some time and some practice to draw these curves, because drawing a quadratic polynomial, the graph for a quadratic polynomial, or drawing the graph of a cubic polynomial, it is not easy. It needs some practice and it doesn't really come intuitively. So we are trying to find out such a curve that passes through all of these points. So for this particular polynomial, your graph should look like this. So now what I want you to do is I want you to pay particular attention to these 3 points. Which are the 3 points? They are this point, and this point. Why don't we write these points? So this point, so that is I'm actually paying attention to the point. So this is the curve, or this graph is for the polynomial px equal to x cubed minus 9x. So for this polynomial, this is the graph of this polynomial. And these are 3 points, this point, and this point, where this polynomial cuts the x-axis. So here the coordinates are minus 3 and 0. Here the coordinates are 0 and 0. And here the coordinates are 3 and 0. Obviously the y value will be 0, right? Because the graph itself is cutting the x-axis. So the y coordinate of each of these points is 0. So 0, 0, and 0. But the x coordinate here is minus 3. Here it is 0. And here it is 3. So why is this important? We will see this in just a moment. Now let's go back. And what we are going to do is, let's rewrite our polynomial, the cubic polynomial, which was x cubed minus 9x. Now, let's say I want to find out the zeros of this cubic polynomial. How do I do it? How do I find out the zeros of any polynomial? Well, I simply equate that to 0. Meaning, at that value of x, the value of the entire polynomial will be 0. So simply by solving this, we can find out the zeros of the polynomial. So if you solve this, you will see, so we can take x common, so we will get x squared minus 9 equal to 0, or we can write this as x times x squared minus 9 can be written as 3 squared equal to 0, or we can write this as x times x squared minus 3 squared can be written as x plus 3 times x minus 3 equal to 0. And why is that? Well, we know there is a formula which is a square minus b square is equal to, we can write this as a plus b multiplied by a minus b. So we are simply using this. So we have x square minus 3 square. So we are writing that as x plus 3 times x minus 3. Now if you look at this, what we have is we have a times b times c is 0. By that I mean we have 3 factors. So this is my first factor, this is my second factor, and this is my third factor. So the product of 3 factors is 0. So it means either a can be 0, right? This can be 0. Then it doesn't matter what is b and c. If a is 0, the entire thing becomes 0. Similarly, b can be 0. If b is 0, it doesn't matter what is the value of a and c. If b is 0, the entire thing becomes 0. And by the same logic, c can be 0. That means x can be 0. The first factor is x. So x can be 0. Or the second factor, x plus 3, can be 0. Or the third factor, x minus 3, can be 0. So if you solve this one, so from here you will get x equals minus 3. Simply by taking the plus 3 on the other side of the equation. And here you will get x equals plus 3. Taking the minus 3 on the other side of the equality sign. So now friends, so for each of these values, so at x equals 0, x equals minus 3, and x equals plus 3, the value of the polynomial will be 0. That is, if you were to find out p0, you will get this is 0. If you find out the value of the polynomial at p minus 3, you will get this as 0. If you find out the value of the polynomial at p equals plus 3, at p plus x equals 3, the value of the polynomial will be 0. So each one of them is 0 of the polynomial. So now if you compare this with what you would have just seen in the graph, you notice that x equals 3, x equals minus 3, x equals 0, and x equals 3. That means just by simply looking at the graph and by looking at the x coordinate, we can say that the x coordinate of the point where the graph cuts the x-axis, that gives us the zeros of the polynomial. Now why don't we take a look at maybe one more, let's say one more example. So this time let's take the polynomial x cubed. Quite simply, this is our polynomial and we want to draw a graph of this. So let's start by minus 3, x minus 3, minus 2, minus 1, 0, 1, 2, and 3. This is more straightforward. So if you have minus 3 cube, we are trying to find out minus 3 cube. So this will be minus 3 cube is 27. Similarly, minus 2 cube will be minus 2 cube is 8. Minus 1 cube will be minus 1. This will be 0. 1 cube is 1. 2 cube is 8. 3 cube is 27. Now let's draw this. So how do we draw this? So we actually draw our axis, x-axis and y-axis. Now let's get all the points. So these are our points, and minus 3 and minus 27, I don't think we are going to be actually drawing these 2 points on the graph, simply because the 27 is way too large a number for us to plot on the graph. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe 12, 13. So we have 14 units. And similarly, we have 14 units on the downside. We would not be able to show 27. So we will actually have to, so these 2 points we cannot use. So we have to draw our graph using these 5 points. So let's go ahead and do it. So what we will see here is that these are the points. So at minus 2, minus 8. So minus 2 is this and minus 8 is this. Then minus 1 is this point. 0, 0 is this. 1, 1 is this. And 2 and 8 is this. So now again, if you have to draw a curve that passes through all of these points, that curve will look something like this. So again here, friends, pay attention. So what you have is, this is the graph, right? This is the graph of the quadratic, or I should say the cubic polynomial x cubed. And this graph cuts this point, this graph, that is the graph of x cubed, cuts the x-axis at one point here. The last one was cutting x-axis in 3 points. So this graph cuts x-axis as 1 point, and the coordinates of this point is 0, 0. So now what we are going to do is, we are going to go back and now let's find out the zeros of this cubic polynomial x cube. So by equating x cube equal to 0, what we have is, so x cube is nothing but x times x times x equal to 0. So if you take a positive number and multiply that by itself 3 times, you will not get 0. If you take a negative number again and multiply that 3 times, you will not get 0. The only way you are going to get 0 here is that if x itself is 0. Right? That means the 0 of this cubic polynomial x cube, the 0 of this polynomial is 0. That is, only at x equal to 0, the value of the polynomial becomes 0. And this thing is very clearly evident from looking at the graph. This is exactly what we saw here. So again, there is only one point where this graph of x cube intersects the x-axis and the x coordinate of that point is 0. So friends, now I think you are actually getting this. I hope that you are able to understand the overall concept, right? Let's take one more example and then we will wrap up this particular webisode. So this time let's take a cubic polynomial, something like x cube minus x squared. A little bit different. So again, we are going to try out these three values: -3, -2, -1, 0, 1, 2, and 3. We are going to try to find out for these 7 values of x, what are the corresponding values of y or px, and then draw the graph for this cubic polynomial. So let's do the first one. So at p equal to -3, you will see that this will be -3 cubed, right? -3 cubed, then -3 squared. So this will be -3 times -3 times minus, it will be -27. Then -3 square is +9, but then you have a minus sign here. It will become -9, and this will be -36. -36. I don't think we are going to be able to draw this on the graph. Let's try now p minus 2. So p minus 2 will be -2 cube, which is x cube, minus x square, or this one will be -8, right? And -2 square is +4, but there is a minus here, so that will be -4. So this will be -12. So this value will be -12. Okay, so at least it is coming down a little bit, so we should be able to draw this point. How about -1? At -1, -1 cube minus -1 square. So this one will be -1 cube is -1, and -1 square is 1, but there is a minus. So this is -2. So we should be able to draw this as well. At 0, well, x cube will be 0 cube minus 0 cube. So this value should be 0. At 1, so this, let's write it here. So P1 will be 1 cube minus 1 square, which will be 1 minus 1 or equal to 0. So this value is 0. X equals to 2. What is the value of this this polynomial? So let's try to see if we can do it from here. So if you were to put 2 here, so that will be 8. 2 cube is 8 minus 2 minus, so 2 square will be 4. 8 minus 4, so this value should be 4. And if it is x is 3, let's try to put it, if we were to put 3 here, so this value will be 3 cube, which will be 27, minus 3 squared is 9. So this one will be 27 minus 9, or 18. I think this will be a big value for us to draw on the graph. So anyway, so let's do one thing. Now let's try to see if we can plot this on the graph paper, right? So here is our graph. So we have drawn our axes, and now let's get all the points. So I have not put the -3 in here. So similarly, I think 8 and 18, 3 and 18, we cannot actually draw this point as well. So we are going to ignore these 3 and -3. So we are going to use these points. So our graph will look something like this. So the first point is -2, -12. So -2, again, we know that, this is the positive for x, this is the negative for x. Now this is the positive for y, and these are the negative for y, right? And we know that this is the origin. So the first point is, our first point is -2, x -2, y -12. So -2, 1, 2, -2, and y -12 is here. So this is -2, -12. The next point is -1, -2. So x -1, y -2. That is the second point. Then we have x 0, y 0. 0 and 0, which is the origin. This is this point. Then we draw the next point, which is x equals 1, y 0. So this is x equal to 1 and y 0. So this point is on x-axis. And the last point that we are going to use to draw the graph is this point. So x equals 2, y is 4. So now let's draw a graph that passes through all of these points. So our graph, you will get something like this. So this line or this graph, this is the graph for the polynomial. Our polynomial is x cubed minus x squared. So this is the polynomial whose graph is shown here. And if you look at this graph closely, you will notice that this graph cuts the x-axis at these 2 points. So this is the first point and this is the second point. So the coordinates of the first point is the origin, which is 0, 0, and coordinate of the second point is 1, 0. So again, clearly the value of the y coordinate will be 0 because these points are on x-axis, but the x coordinate here is 0 and x coordinate here is 1. And as you can imagine, I'm putting emphasis on the x coordinates here. Why? Because you can simply guess that if you were to calculate, actually, why don't we do it here and see if we have enough space here to do this by ourselves. So if you were to find out the zeros of this polynomial, right? Your polynomial is x cubed minus x squared. X cubed minus x squared. So if you were to equate this to 0, and if you take x squared common, so you will have x minus 1. X squared times x minus 1 is equal to 0. So this factor is 0. That means x is 0. And otherwise, this factor is 0. That is x minus 1 is equal to 0. Or solving this, you get x equal to 1. In other words, at x equal to 0 and at x equal to 1, the value of the polynomial x cubed minus x squared is 0. So both of them are zeros of the polynomial. And simply by looking at the graph again, it is precisely at these 2 points, that is at 0, 0 and 1, 0, we see that this graph cuts the x-axis. So friends, from here we can actually conclude that, and this is pretty much what we have been seeing throughout, which is that geometrically speaking, the zero of a cubic polynomial, or we should say at this point for any polynomial, is the x coordinate of the point where the graph of the polynomial intersects or cuts the x-axis. And the other important observation to make, friends, is that we see from the graph that a cubic polynomial can have either 3 zeros as shown by our first graph, or 2 zeros, or 1 zero, or it may not have any zeros at all. That is, at most it can have 3 zeros. And again, this goes back to the fact that a cubic polynomial has degree 3. So it can have at most, maximum, it can have 3 zeros of a cubic polynomial. It may have less than 3, that is, it may have none. It can have 1, it can have 2, it can have 3. It can never have 4 or any more than 3. And just very briefly, so this was the example, I think, where we saw 3 zeros of a cubic polynomial, right? In this example, we saw 1 zero of a polynomial. And in the last example, we saw actually 2 zeros of a cubic polynomial. So friends, I hope that you have been following us along at risingpearl.com. We really have covered quite a bit of ground in terms of understanding the linear, quadratic, and cubic polynomials, and how do we graphically draw them, and how do we calculate the zeros of the polynomials, and how, by looking at the graph of these polynomials, we can tell what are the zeros of those polynomials.